let's get started. I have already received your updated list. I mean, the list of your name, phone number. But I mean, I need to know, is it like that I mean, when the last digit of your student number starts with 1, then you belong to section A. If it is 2, section B, C, then section 3. Is it correct?
Yes, sir.
Okay. Then I think also, I mean, when it is 59, he is from section A, right? I mean, 059, right? 59. Is he also?
I'm in section B, sir.
Oh, really? Okay. So if the last digit starts with 1, from section A, but there is an exception, and there's a 059, Fayaz Zarif Hussain. You are from section B.
Yes, sir. Section B, sir.
And there is Atik Abrashurov, 049 from 16 batch. What is, Walaikum Assalam. Which section do you belong to?
Sir, I belong to section A.
Section A. Thank you very much. Okay. Now I have already shared the early class notes, the Google Drive. I have shared the link for the Google Drive, and our main textbook, the book written by Rappaport, is also there. And our last every time we have a online class, I'll be uploading. The last class is already there. Okay, let's go back to our discussion of different types of wires or cables. We were talking about twisted pair, and things we have covered. Okay. Now, there are two types of twisted pair cables. These are copper cables. You cannot use this copper wire. I mean, the ordinary copper wires cannot be used for communication purpose because I mean, although this twisted pair cable is one type of copper wires, but in the form of little bit special configuration. And the other two types of wires, two or three, coaxial cable, optical fiber, waveguide, they all have a lot of different, I mean, very special configuration, as we're gonna see shortly. You might ask why we need a special type of configuration for the cable. For ordinary power transfer, you can use copper wires, thin or thin. What's wrong with that? The problem is that in the case of communication, you have to use very high frequencies because you need to support a wide range of bandwidth to transfer huge amount of information. For power transfer purpose, you may use a single frequency. So the frequency bandwidth is not wide, maybe just a single frequency component. But in the case of information transfer, the bandwidth matters, not the power level. So you need wide range of frequency. That means the upper limit of the frequency will also be very high. So you have to use very high frequency wire. And then the wavelength will be very short. And if it is very short, then your wire may start radiating energy. Why? Because it can start working like an antenna. An antenna radiates energy, and that depends on its particular design configuration compared to the wavelength of the signal. Okay. We'll look at these things in more detail later in the course. But for now, let me tell you, uh, you have, when you use high frequencies, then the ordinary copper wires will be radiating too much energy. And shortly, your energy will die out. You may be using small energy for communication purpose. So that will die out at a short distance if you use ordinary copper wires. You have to use some special configuration. The twisted pair cable is at the lowest end. Okay. It can support at the smallest bandwidth in the ordinary configuration as well, but nowadays there's a lot improved version of twisted pair cables, as we'll also see. Okay, but or, originally you have the lowest frequency support with twisted pair, because it's still copper wire with some with a very little uh, uh, change in the from the original configuration. Anyway, so uh, so we have special types of cables for. I mean, by special I mean that the cable configuration is different from what you use for power transfer purpose, or what you have used in, say, in electrical circuit lab, or in machine lab, in in some power courses. You can hear me, right, guys?
Yes, sir.
Yes, sir.
Okay. Now, this twisted pair cable can have two types. If you have a good shield, I mean, UTP is unshielded, but we actually have a small layer around the twisted pair cables. But in the case of shielded type, STP, then you have a very good foil jacket around the whole thing. That can prevent interference from outside very well. So in the case of UTP, you use a layer just to protect the cables inside from physical bump, or uh, any kind of physical intervention. So if cables are not damaged. Uh, so it is physical shielding. Sorry, it does not use. Sorry, what he mentioned here, that it does not use shielding to block interference, but so it is. We are showing that there is no shielding, but you can see that there is a small layer. So that's like to protect from physical bump or something. This UTP is cheaper compared to STP, and that's why UTP is mostly used. And the Ethernet cables you see around are actually UTP. You may already know that there are different categories, and they are called Cat 1, 5, and uh, mostly you may already also know which types you are used. You may be using some broadband connection at your home. Some Ethernet cables may be serving you. So if you just read the label on the cable, you'll see the category. So I just thought it might be good for you to be familiar with the different categories so you can compare. The pressure types are most, will be either 5 that you see around. Will either 5, 5E or 6. If you read the label of the Ethernet cables, it will be one of these three, 5, 5E or 6. For old installations, it should be 5. Now, this table shows that for higher grade cables, you have better capabilities. In terms of what? In terms of data rate and the maximum length that you can support. So you have without any, the length, we are actually talking a little bit about optical fibers. And then we mentioned that over certain lane, the energy becomes too weak. So you may not be able to detect your information, retrieve your information. So you have to then use some repeater to regenerate the signal and transmit it again. That's what is done underneath the ocean for submarine cables. So you run the optical fiber, and after some certain length, the energy attenuates too much. So you have to regenerate the signal and transmit again. So there is, for any type of cables, there will be attenuation and propagate. There is some attenuation. So there will be certain length over which you can use the cable at the maximum. So that length is given here for different types of cables, and it's actually 100 meter, as you can see. But we'll show that sometimes with high data rate, okay, the length can be a little shorter. Anyway, this the data rate support increases for higher gate cables. The maximum the data rate, the upper limit of the data rate relates to the maximum frequency that you are using inside. We later discuss the relationship between digital data rates and the frequency bandwidth. They relate. Or you may already have some idea. There is channel capacity theorem. This is the basic way to relate the frequency bandwidth with the data rate, digital data rate, BPS. Anyway, so this relationship, as you increase the data rate, digital data rate, you need larger bandwidth. Okay. Now there is also Cat 7 and Cat 8, but I don't think you find them around in our country in audio installations. In a special way, you go to NOC network operation center or somewhere, then you may find it. Cat 6A, but you can find Cat 6A in some data centers. Now, a bit more about them. Cat 3 actually is 2 volt. You may not find it. Cat 5, oh. You see the screen?
Yes, sir.
Cat 5,
Sir,
yeah.
sir, when you're talking, sir, we are listening, but sir, when you're talking for a continuous time, sir, that a little echo still coming back. It's like we're losing a lot of the words you're saying in between,
Oh,
sir.
really? Okay.
Yes, it's very difficult to keep track, sir. So I'm constantly getting lost, sir. I'm sorry, sir. But
I'm sorry, I don't know the reason, but
yes, sir.
I guess it may be because of my headset.
Okay,
And
Can
so
you try
I
one?
from next week I'll be using a new one,
Okay,
and let's see how it goes.
thank you, sir.
So this time, what I can do, I can detach the laptop, detach the headset from laptop, and I can try using the microphone of the laptop. Do you think I should try that?
Yes, sir. Yes, sir. Use the microphone
You
of the
can try it, sir, but sir,
Okay, that may worsen. So just
have a
respond to me how it happened.
Okay, sir.
Let us just test it first.
Yes.
Okay, now I'm using the microphone of the laptop. How's it working? Do you
Yes,
Yeah,
sir.
hear
It's
me?
actually,
working
it's
very fine.
better, sir.
It sounds better?
Yes, sir.
Okay.
Yes, sir.
Okay. So the Cat 5 can support up to 100 Mbps, and if you know, is quite good. And Cat 5e can support up to 1 Gbps, and which is called gigabit network. Okay, you probably know that fast Ethernet. Okay, sorry, it was called fast Ethernet when people started using started supporting 100 Mbps. Okay, you guys are, I mean, in when I was in 90s, okay, like before 2000, I mean, since we uh, had some, we had to face some networks even in 1990s. Okay, so we know that this fast Ethernet was not there. Okay, so for me, fast Ethernet is something advanced, but for you guys, it's not. So anyway, so for you guys, Gbps or gigabit Ethernet is the advanced thing, and when you can support Gbps, and Cat 5e is the first one to support in the Gbps order. But in that case, the maximum length is shorter than 100 meter. Uh, but okay, the maximum length can be 328. I have it in feet, and also the delay is little bit higher. Delay means we later explain what we mean by this delay. It's also called latency. Uh, it can affect the performance of some application. For example, say just consider live streaming of say cricket match. So if there is some delay, then for your network, then you may find someone to hit six, but and you then cheer, but from someone else in the neighborhood may have cheered or may have shouted a while ago because the latency was smaller for him. Okay, so the latency, the time it takes to transfer the information does matter, and that's called latency. So the latency can be different in different networks. So someone will receive the intended data earlier than the other. So the delay can be little higher for 5E. So higher grade cables are better in all respects. And so Cat 6 can support up to 10 Gbps. And if you and but the maximum length is up to 164 feet. And if you use even longer length, then you have the same data support as you have for 5E. I mean, up to 1 Gbps. Cat 6A. Sorry, give me a second. Actually, by 100 meter, equals to 328 feet, right? Oh, sorry. So 328 feet is the standard for Ethernet cables, the standard maximum length. So it falls below that, it falls to 164 when you use up to 10 Gbps with Cat6. But if you use Cat6A, then you can go back to the standard length, 320. You can support up to 320 feet, 328 feet with even 10 Gbps. Okay. So Cat6 A, I mean, in the usual deployments, they're saying that I mean, you should find 5E, or 6. Okay. And in some existing deployment, you can find that Cat5E is used up to the workstations, up to the uh, say for example, your Wi-Fi router. If you are using broadband, may be connected using Cat5E, but the guys who are serving you may be using Cat6 for their own backbone. So when they are connecting their switches, they are using Cat6, okay, to make sure that they don't restrict the data rate. Make sure that your cables are not restricted the data rate. But nowadays, mostly, it's not exactly in our country, but around the world, mostly people are using Cat6, Cat5. People are uh, don't use any longer in most cases nowadays. In our country, people still use, but Cat6 is mostly used around the world nowadays, and sometimes Cat6A. Uh, so the cost is definitely higher as you go for higher grade cables. For Cat6, it is roughly 30% higher cost compared to Cat5E, and Cat6A is again additional. It will again cost additional 30% compared to 6.
Sir,
Yeah, yes, go ahead.
so this type of improvement in cable, I mean, this type of improvement in cable, what actually the physical change between that that is available in the higher end cables? I mean,
Okay.
6, 6, 8,
Yeah,
which is not actually.
yeah, that's a good question. Okay, there are, for example, first of all, I mean, if it's difficult for me to compare the cable types which are very close to which are very close grades. Okay? But if you look at I mean, very old cables with the recent ones, you will find different number of twisted pairs inside. Number of pairs will differ, and I mean, different pairs are used for different purposes, and you'll see different arrangements there. The voltage levels will differ. The rate of twisting will differ. So in many different ways, the configurations differ.
Okay, sir. I mean, the main theme is same, that twisted pair, but rate of
Yeah.
twist and the number of pairs available in a cable, these things will differ.
Right. Voltage
Okay.
levels and different things. So STP also use twisted pair cables, but I mean the Ethernet purpose you can use STP, but then you have little better performance. But people seldom use STP because it's additional cost, which does not seem very essential. It suppose it gives a pretty good performance. So here's a quick comparison. ETP are prone to noise and interference in this course. Okay, let me tell you now that this course will be a lot different from all the courses you have taken so far. We'll try to keep up with what is happening around, okay, in the industries or commercially, how people are really using different things for wireless communication or telecommunication in practice. Okay. It's not like you learn a lot of theories and you know how to do different math, but you don't know what is going on around. Okay. That's what you have done in all the courses, I think, in all the courses so far. But this course it will not be a very difficult course. Okay, will not bombard you with very difficult theories or difficult problems. Okay, very high level math. No, it will be very it will present very simple stuff, but mostly about what is happening around, what is happening in the industries, what's happening, okay, commercially or in practical deployments, what people are doing. And I update the course lectures every year so that I mean this information remains cutting edge. Since I try to uh, get connected to the industries, or I want to keep you in touch with the industries or the same pace. So it has to be uh, updated, okay, updated with what is happening around at present. And this is why don't try to collect the class notes from your previous, uh, I mean, uh, the senior brothers, uh, and the questions. This is true for my all of my courses, and I have been doing that for, throughout my whole teaching career. Uh, so the questions can vary from year to year because the syllabus itself varies, at least to some extent. Okay. Uh, so probably you'll get the knack about how to, it will help you more after graduate. Okay. And some of, some of the alumni really reported to me that my courses they found mostly useful after graduation as they joined the industries. They found my courses mostly useful. More useful compared to all other courses. Okay, now, so this, a lot of times we will also try to, I say, uh, uh, I'm giving you some comparison here. So that I'll do at different stages. So you can choose uh, the right thing when you have different options. Okay, in front of you. Okay, now here we have a quick comparison: UTP versus STP, and very simple. UTP is more prone to noise or interference, but it is less expensive and it is cheaper. Okay, you all know. Very simple. This course is simple. Okay. Coaxial cable. Well, the configuration for coaxial cable. Uh, Actually, it's also not something that you're not familiar. Uh, like if you have, I don't have TV at my home, but if you have one, then you may be using also something. If you are using dish antennas or something, then you may be using coaxial cable to connect your TV. Or at least you all have used oscilloscope and you had probes, and the probe was connected using coaxial cable. The props that you had, you had coaxial cable all the way to the oscilloscope, right? So it was a coaxial cable, and so the configuration inside is nothing but you have two metallic round shaped uh, structures. One is at the center, just like a rod, and there will be a spacing around the center or inner conductor. It may be just the air. Most of the time, it is just the air. For our present picture, you have some other material, dielectric material, means some insulator, okay, around the center, and then you use the outer conductor. Okay. And around that, you have some plastic jacket to save it from physical harm. Okay, so the configuration is very simple, but this coaxial cable can support high frequency signals. So you see, it has a special configuration. It's not like your ordinary copper wire, and that can help you confine the energy. The ordinary copper wires, I am reiterating, has the problem that it will radiate energy. There will be an antenna-like action if you use high frequency. But this coaxial cable can confine the energy inside. The fields will be inside, will be in between the two conductors, and the electromagnetic wave will flow inside. Now, the inner conductor or the core conductor and the outer conductor are actually made of copper, and it can support higher data rate because it can support higher frequencies, and there can be okay, now the impedance at the end is usually 50 ohms or 75 ohms. Okay. So there should be an impedance matching when you're connecting. I mean the cable itself has an impedance concept that's called characteristic impedance. This thing we will okay we'll talk a little bit about that later, but there is actually I offer a course in the 8th semester, microwave engineering. In that course, we cover the high frequency mediums which you can use in circuit. Is say coaxial cable, waveguides, and except optical fiber. Optical fiber falls in the optical frequency range. But all these things support radio frequencies. So that course discuss these things, and the impedance matching, characteristic impedance. These things we also explain in more detail there. But for now, let me tell you that it's like as you run the cable or for any part of circuit, if it is like that you maintain the same impedance. I mean, if you look towards certain direction at a point in the circuit, you'll find some impedance, which you may call input impedance. Now, if this impedance does not vary over a good part of the circuit, if it remains constant, then it is called characteristic impedance. Okay. Actually, later in another slide, we'll little bit talk about that. So this coaxial cable, okay, or any type of cable you use, has the maintains impedance. So when you buy the cable, you will find a specification. So if you want to buy 75 ohm cables or 50 ohm cables, that means it is the characteristic impedance. Then, but which one you should buy? It depends on where you are connecting to. The place you are connecting to has some input impedance. These two impedances must match. The input impedance where you are connecting and the characteristic impedance of your cable must match. And so if it is 50 ohms, then you okay 50 or 70, 75 or whatever, you choose the cable accordingly. So you need to know what you have. Again, in a quick comparison, well, first of all, it is better shielded. Coaxial cables are better shielded from. You have the wave confined inside, and the outside signal cannot penetrate because you have metallic outer conductor. So those signals, EPS cannot go inside, and your field also doesn't come outside. Okay, so if a coaxial cable will not interfere another coaxial cable, like what you have in twisted pair cable. We talked about crosstalk, which was like you have multiple twisted pair cables together. Okay, so usually the present category cables have four pairs inside. So one can interfere the other. So that's called crosstalk. But if you have even 10 coaxial cables together, there will be no interference among them. Because one does not, the signal does not go out of the cable. Neither the signal from the outside can penetrate. So it's better shielded. And we'll also later discuss how the interference can impact your data rate. So you might think, okay, what is the problem if I have the interference? The interference will degrade your data rate. Ultimately, the data rate will fall, will experience lower data. Anyway, now the bandwidth is higher, or you can support higher data rate for coaxial cable. But this point is sort of vague. Okay, I'm telling you, because it all depends on what type of twisted pair cables and not the coaxial cables you are using. At present, very advanced configurations of Ethernet twisted pair cables are available. It can support very high data rate already. On the other hand, coaxial cable has a bandwidth which depends on its thickness. Thinner cable supports larger bandwidth. If your cable is thick, then the bandwidth will be smaller, not the other way around. So it depends. When you want to compare twisted pair cable and coaxial cable, you need to know what type of twisted pair cable you're comparing with what type of coaxial cable. Okay. However, a general comparison is like that. You have one twisted pair cable with just one pair and one standard configuration. Yeah, is coaxial cable. Then your data will be roughly 80 times larger in the coaxial cable. And also you can support greater cable length. The signal loses energy very slowly. So these are the advantages for coaxial cable. Maybe nowadays people Ethernet cables have very good capacity. Okay, but in the past people used coaxial cables a lot for LAN. These cables are less expensive and you can install it fast. This was a set of advantages of coaxial cable over twisted pair. Now, disadvantage or advantage of twisted pair. It's less expensive. You can install very fast. And finally, it is sufficient to support your requirement. So it will be cheaper. You can use it very, it's handy. You can install it fast. So, why go for the complexity with the coaxial cable? That's the point. That is why coaxial cables are not very popular for Ethernet type of applications. But it has its own place. Coaxial cable has some own applications, like the oscilloscope is using coaxial cable. And if you do the microwave engineering course, then you'll feel uh, better, okay, for the application areas of. Anyway, then the optical fiber for long distance data transfer, high speed data transfer is the only option. Around the world, people are just now adopting optical fiber everywhere for long distance high speed data communication. So we'll also see later that we have submarine cable, optical fiber. We have terrestrial optical fiber along with power lines from India. So these are the two ways we are receiving internet service. We are connected to the world, to the global internet in these two ways: submarine cable and the terrestrial optical fiber from India. And the configuration has you see very thin core at the center. Transparent, because optical fiber, unlike all of our previous discussions, don't use radio frequencies. It uses optical frequencies, very, very high frequencies. So these so it's light, and you have a core made of glass or plastic at the center, and you see the core is very thin. The whole optical fiber, you won't find that thin, but the actual core part is very thin, and the whole signal flows through the core. The core itself, only the core. And around the core, you have another layer, cladding, but that is a different refractive index. So because of the difference in the index of refraction, you have complete internal reflection inside the core. The signal doesn't go out or doesn't go beyond the core because it finds, every time it is incident on the surface of the core, it has a complete internal reflection. So it comes back to the core. So it is confined within the core. And the other layers are to protect it from physical impact, from damage, moisture, or whatever, buffer and jacket. Now again, comparison among our different options. The optical fibers permit transmission at a very long distance at a very high data rate. So very large bandwidth, so very high data rate in the order of terabps, okay, not Gbps, order of terabps support, and for many kilometers. But it is more expensive. So when your Ethernet cables or coaxial cables are sufficient for your service, why go for optical fiber? The fiber itself is not very expensive, but for the total setup, you have to have transmitting side and receiving side, which have the fiber optic operation. So the whole setup is expensive. Okay, so it's the only option for sending large volumes of data. The final option, waveguide, actually this is we cover it in microengineering course. Within circuit, you use waveguide, or say when you have an antenna, it may from the circuit it can be connected using a waveguide. So it looks like a pipe. The cross section may be rectangular or even circular. If it is circular, then it looks pretty much like water pipe. It's metallic, hollow tube. Now, these last two types, okay, the optical fibers and this waveguide, is single-sided. Single-sided means for all the courses before, for signal transfer, you had two sides. So you had two wires to send the signal, right? Always you had two wires for electrical power transfer. The source connects the load using two wires. So you always had two wires to, the current goes in through one wire and through the other wire, it comes back. So this way, you had always two wire connections. And that is also you have for twisted pair couples. And then coaxial cables, you have two wire connections. But in the case of optical fiber, you use light. So you have a single volume only as the core. You don't need two sides. Two sides separated, of course, separated by some insulator in the ordinary cases. But optical fiber, now in the case of waveguide, it is again one-sided thing. You don't need two sides. It's like a hollow tube, like a pipe. So all the way connected around the cross section. So if it's like a tube, metallic tube, just like water, think about the water pipe. It's all the way connected. It's one-sided at the cross section. So you may be surprised how it then works. You need two separate sides, right? It works this way because it can work only at high frequencies. When you have a small wavelength, and at this small wavelength, you have a complete change of wave or the signal variation within the waveguide. And so the two end, it falls to zero. The voltage difference falls to zero, where you can short or you get the whole hollow tube configuration. Anyway, the detail.
Can you kindly repeat?
And that may be the better. Yeah. What is the question?
Sir, could you kindly repeat, sir, the two-part, one-part thing, sir? That is a little unclear, sir. I couldn't understand it.
Sorry?
Yeah, the two-part, one-part, that thing about that optical fiber and other cables. Other cables have two parts, and optical fiber has a single part. Then you said that waveguides also have a single part. So how is it so? Can you kindly repeat that part again?
Okay. Well, I didn't want to highlight this point because we cover waveguide in microengineering course. Okay. It will be crystal clear why a single-sided or how a single-sided configuration can work. So here, all sorry. Say maybe just work to mention that in the ordinary configurations, you always have two sides, right? So far in all courses, you have used cables which has two wires. So that is what you also have for twisted pair cable. Say every pair can independently transfer something. So you have two two wires. And the same is true for coaxial cable too. Coaxial cable also has inner conductor and outer conductor. So you have actually two sides. So you are connecting a load. You're connecting a load to that. So I mean, one side of the load will be connected to this point, the inner conductor. The other side will be connected to the outer conductor. Well, the coaxial cable, for coaxial cable, the outer conductor is connected to the ground. Okay. So if you are connecting, say, a source to the load using coaxial cable, then the outer conductor, I mean, the ground side of the source and the load, okay, connected to ground, and they'll be connected to the outer conductor. And then the higher polarity side will be connected to the inner conductor. Okay. That's how you complete the circuit. So you have two sides to connect to use it in the circuit, like the ordinary wires, the ordinary copper wires that you used in other courses. However, the last two examples are different. For waveguide, I don't have a figure here, but it is not required either. You just think about water pipe. Okay. There is a waveguide. Waveguide has different shapes. One of them is circular waveguide, which is exactly like water pipe configuration. It is also metallic and it has water pipe like configuration. Just the finishing is much better, very precise finishing you use for when you use it as waveguide. But it is just round shape, circular shape. So in that case, you see there is no other side. It's just one-sided, right? You have metallic round shape, a hollow shape, okay, a tube shape. But there is no second, like you have for example, for twisted pair. The two sides, any tube, the two wires in the pair must have some insulation between, right? There will be definitely insulation. Definitely insulation for coaxial cable. There will be definitely insulation between the two sides. But in the case of waveguide, think about the water pipe. There's just one-sided option, one-sided configuration. You don't have another thing, okay, which is separated. No, just this one-sided configuration, and that can carry power, that can carry signal. But I think we may not spend more time here. If anyone is interested, then he can contact me, and because it will take a while to properly explain how a single-sided structure can work. But let me tell you, it can work only at high frequencies. When the wavelength becomes very small, the wavelength has to have a dimension comparable to the size of your waveguide. Okay, so there will be, say, the width can be multiples of wavelength. The width, okay, of your waveguide can be some multiples of your wavelength. So that's how, the wavelength in the, within the wave variation, it falls to zero. Okay, so the voltage comes to some zero level, and that's how you create some shorted option. This one-sided option is like a shorted option. So you can go for it. But I think if anyone is particularly interested, it is worth discussing it with him. For now, we can stop here. But we'll have the reason I mentioned it in the web guide that to list actually to have a complete list of different types and also to have a comparison. And let me tell you that optical fiber is also one-sided thing, but it is not. You are not using electrical signal here. For optical, you have gone beyond the radio frequency range. You are already in the optical range. It is light. So the light goes through something single-sided. Yeah, the electromagnetic wave is flowing uh, through the core. So this also single-sided up. Okay. So I just wanted to have a comparison of the waveguide with other uh, options. Say the waveguide is used in the circuit, okay, for short distance only. Like for optical fiber, you use I mean, you may have a requirement of large distance data transfer. For this kind of applications, you can never use a waveguide. Waveguide is first of all very expensive, very expensive. So short pieces of waveguides are used within the circuit. For long distance, you can use. Well, uh, the longest use for waveguide is like when you are connecting your circuit to the antenna, and the antenna may be located outside. If you have a very large antenna, like large dish antennas, for example, the Earth center of satellite has a very large dish antenna. I mean, the radius maybe 20 feet or something, or even larger. It will be located outside the building. So you then have to connect your antenna, this antenna to your circuit. Okay, then you may use waveguide with up to the antenna. So these are the longest examples for waveguides. Now the waveguide is very expensive, as you can see here. It's very expensive and it is bulky, heavy, very heavy. And also the bandwidth is not very large compared to optical fiber. The bandwidth is very small, but compared to other options, it is large. Here, small bandwidth. I mentioned comparing it with optical. Okay, and it has low losses. Okay, that's good. But you don't use it unless you have no other choice. Okay, because it is expensive in bulk.
Sir,
So then when you use it, let me just finish this last point. Then when you use it, well, when you have a requirement to transfer using very high power, you have a high power requirement. High frequency you can support using other options too. But now no other option can support high power. If you have a requirement that you also need to transfer the information with high power, okay, then waveguide is the only option. Okay. Now I'll just give an example when you may require high power. But before that, let me take your question. Okay. What are you asking?
sir, how is the data transmitted in a waveguide? Like for optical fibers, we use visible light.
Yeah, it is like coaxial cable. You have electromagnetic wave propagating inside.
Okay, sir.
It's like a pipe, but instead of, I mean, it doesn't carry water. It just carries electromagnetic wave. Like coaxial cable, the wave doesn't come out of the waveguide because we have metallic confinement, and also from outside we don't have any interference. So it is just like, I mean, for wireless communication, you transmit the signal using an antenna and let the signal propagate free. So that is called free wave. the electromagnetic wave propagates free when you launch the signal using an antenna, like your mobile phone is transmitting. So it is launching the signal, and the signal, the wave is then free wave. But if you want to carry, if you want to let the signal flow within your circuit in a guided way, then it is called guided wave, and that you do using waveguide. There's some waveguide through which the signal, the electromagnetic wave will propagate. It will not propagate, it will not disperse. Okay. The free wave disperses, but here it will not disperse. It will be confined within the waveguide and propagate the wave in the direction you want. You can use bands. You can use, just within the circuit, you can take your signal in different directions using waveguide. Okay, really, you can use bands. You can have a straight waveguide, then you can use some band to have a turn. Okay. All these things are possible. But why you need high power? Okay, that could be a question. Well, you will have a industrial visit at the end of this year, and some art centers. Okay. We have an art center at Banani, art center for satellite, and there's also one in Kaliapur. Okay. I think you'll be visiting Banani art station. So the signal, now I'll tell you something which we'll discuss in detail later. But just I'm giving a hint that when you send the signal, you have to consider how the attenuation of the signal on the way. So the signal loses energy on the way, and at the receiver, you have to have energy barely enough to retrieve the information. So the receiver actually always, for wireless communication, invariably receive the signal at a very weak level. The signal strength is very small. But from the transmitting end, you have to use high power. Okay. So that at least that small level of energy is available at the receiving end. Okay. To make sure that at least the minimum required value of energy is available at the receiver, you have to use high power at the transmitting end. But even with the high transmitting power, the received power will be low anyway, because the signal loses a lot of energy on the way. Now, for the Earth station, it has to transmit the signal at very high power because the satellite is located far away, very far. So a lot of energy will be lost on the way. So you need to use very high power for transmission. But the same antenna will also be receiving signal from the satellite. The antenna works for both transmission and reception. Okay. So it has double role. So when it receives signal, the signal level is low. But the satellite transmitted with high power, but that at the Earth station the signal arrived with low energy, so you receive the signal low power. So for transmission, you are connecting your circuit to the antenna. So when from your circuit you send the information that you want to transmit, so you need to send it with high power to the antenna. From the circuit, you need to use the power amplifier to raise the power level of your information signal to some very good level of power. And then this high power signal you need to carry up to the antenna, which will launch. So to carry this high power signal up to the antenna, you have to use waveguide. I mean, you have to resort to waveguide. There is no other option to carry this much high power. No other option will be able to carry this much high power. And it also has high frequency requirement. Okay. So if it was a low, I mean, of course, I mean, for low frequency of cases, high power you can easily carry, right? I mean, say the power transfer lines are carrying megawatt of power. So ordinary frequencies you can carry with high power using ordinary configuration lines. But here you have requirements of both high power and high frequency. You need to operate the with very high, very large bandwidth for satellite communication. So high frequencies will be used there. So for this twofold requirement, both high power and high frequency, waveguide is the only option. Okay? There is no other option in the world. So you have to resort to it. But these requirements are not very common. You know that, I mean, only this in the certain cases you need it. For example, even for the receive power, you don't need a waveguide. When the wave antenna is receiving power from the satellite, and that received information you are bringing back to your circuit. Okay, you don't need to use the waveguide. So for the signal which is coming back to your circuit from the antenna, waveguide is not used. Rather, coaxial cable is used. So when you visit the Earth Center, please notice this thing. You will see that two different things are connecting the antenna outside the building, from your circuit inside the building. Two different things are going to the outside antenna. One is the waveguide, the other is coaxial cable. So then you should understand that the waveguide is carrying the power for transmission from the circuit. The power signal is going to the antenna for transmission, and the coaxial cable is bringing the signal from the antenna to your circuit. The low power signal, information signal, is coming back to your circuit. Okay. Now questions. There are different types of waveguides, but you know that those things will be covered in microwave engineering course, not here. Guys, are you there, or you have fallen asleep?
No, sir. Hello, sir.
You're still awake? Very good. Very good. Okay. I thought it was a very boring course, and most of you. Okay, maybe it may be like only a few are still awake, and you are responding. The rest of the class is sleeping. Okay. I don't know. I mean, your video turned off, so you can take this advantage in these online classes. Okay. So, any questions? You have just 2 minutes.
No, sir. That's fine, sir.
We have completed this lecture. We will move to another presentation the next week, and the early lecture notes are already available in the Google Drive. And if you have any questions, you can actually contact me anytime.
Sir, could you kindly share the Google Drive link in the chat box?
Okay. Okay. I will share it in the email, and I'll do it here.
Okay.
Give me a second.
So,
Yes. Yes, good.
I think it's better you create a Google Classroom to be sharing the links and the class likes than to be sending links all the time to our Gmail.
Say that again, please.
I said, I think it's better you create a Google Classroom where you will be sending
Oh,
all
in
the
the
lecture.
classroom? Yeah, actually, I have shared it in the classroom, but I'm not sure if you join after my sharing, whether you can see it or not.
Yes, sir, we can see it.
Okay, then you should find it. I've already shared the link in the classroom as announced. But when I shared, only one or two had joined. I shared.
Yes, sir. Yes, sir. The mail came at say 8:53 a.m., sir. So
Yeah.
I think a lot of people did not check it, sir. Myself, I did not.
Yeah,
check it
I mean
till now.
also the classroom. I have created a Google Classroom.
Yes. Everybody got it, sir. Inshallah. Thank you, sir. My bad.
In the Google Classroom also I shared the link, but many people haven't joined the classroom. Now I can see most of you have joined. Okay. So if there are no questions, then I think we can stop today. Jazakallah
Thank
for
you,
your
sir.
time.
Yes, sir. Assalamu alaikum, sir.
Wa alaikum assalam.